what is incident, what is problem, what is service request, what is the type of customers, what is service desk do, what is service desk person will do it, what is SLA, what are the type of tickets, levels of service desk, and of course explanation about event, alert, different events from the op managers, alerts we can see, incidents, problems, and change management, and a service request we discussed, right? And also I told about priorities and impacts kind of stuff. What is the priorities? Okay, so and the basic questions from here. So I didn't give you more details about a okay, what is like monitoring tools and service desk tools. I didn't told you. If I have any chance, I will tell. Okay, but today I want to start with the networking. Okay, networking is a very lengthy topic, guys. Out of all topics, so compulsory we um, need a time. So we'll see. So tomorrow also class is there. Tomorrow is not a leave. Okay, tomorrow morning we have a class, same time, so no difference. Okay. Because this networking is a lengthy topic, so we should not give up a time. Okay. So first of all, I will give you a small overview what we are going to learn. Okay, so we'll see that one. Minimum 3 days it's required for a networking. 3 days. So we have to finish by Monday. So we have a free time on Sunday. So read about a service desk. Of course, you must read daily about service desk. Okay, so Sunday by Sunday, we should complete both the parts. Sunday we don't have a class, so I will inform about Sunday. Okay, now we are in a little rush mode. Okay, so network, about what is network. Okay, and types of network, different topologies. Okay, different topologies. What is NIC? What is MAC address? Okay, how to check IP address and MAC address. Okay, different type of cables we use in the network. Okay, and also different devices like a hub, switches, routers, modem. These 4 devices are very important devices. So what are the devices we use in the network? And OSA layers and IP addresses. This is about IP addresses, IPv4, IPv6. Okay, so before IPv4, IPv6, I will tell about OSA layers. OSA layers. And in OSA layer, another important part is there. So protocols, different type of protocols and their port numbers, TCP, UDP differences. And this is how packet is travel from source to destination and destination to source. Means one PC to another PC, other PC to our PC. Like how it is goes. Like how you send, how you receive. That's the part. Okay. Some commands we use in the networking. What are those commands? Okay, and troubleshooting using OSA layer. So if possible, I will try to explain this one also. We have to make a time for that one. And NAT PAT techniques. What is NAT? What is PAT? So these are the topics we are learning in our networking basics. So I put a heading is networking basics because we are not learning networking. We are learning the basic part of networking only. Learning of networking means not only this, about all services related to networking, like DHCP service, DNS service, routers, routing concepts, switching concepts, VLAN concepts, all these things we have to discuss here. But we are not discussing that much, right? We are doing networking basic part only. Okay, so I'm going to start from here. Guys, already I shared a link, PPT link to you. So this is a PPT link. Okay. So you can access the PPT, and of course, most of the thing I will put it in a my here. Okay. Okay. The first thing is, what is network? What is network? Okay. What is a network? So, and that is networking. What is network? What is networking? What is internetwork? What is internetworking? Okay. Okay. I am giving the link here also. Okay. Interconnection of two or more devices is called a network. Interconnection of two or more devices called a network. So you have a devices. So we use a device word. Why device word, guys? Nowadays, not only a computers, your mobile phones, laptops, okay, so many devices are the TVs nowadays, right? These are all connecting each other, right? So either directly or indirectly, how it is connecting. We are connecting the devices, okay, either two or more devices. It can be a two devices or more than two devices, not one device anyway. Two or more devices we are connecting, that we call it as a network. That we call it as a network. What is networking? What is networking? Communication between two or more interconnected devices. The communication between two or more interconnected devices. For example, there is a devices like APC is there, VPC, CPC. Okay, the communication between A and B. Okay, or maybe communication between A and B. Okay, these devices are connected, then they are communicating each other. If there is no connection, they can't communicate. I showed just generally the wide connectivity, wide or wireless connectivity. First, they should connect it, then they can able to communicate. That is called a networking. Communication between two or more interconnected devices. Okay, interconnected devices. Next one is internetwork. What is internetwork? It is a internetwork. I have a network like this. Okay, there is a different networks are there. Maybe in the same organization or maybe different organization. There is a different networks are there. These are the different networks are there. Okay, this is another network. This is a network one. This is network two. Or like that, you have a multiple networks. What I have done, I connect these networks like this. Interconnection of two or more networks. It's a connection of two or more networks called a internetwork. Connection of two or more networks called a network. Communication between these devices. Okay. For example, A can able to communicate it to E. C can able to communicate it to F. Means communication between two different networks, two or more different networks called a internetworking. Internetworking. Okay. So internetworking means communication between different networks. Okay. Just I want to try a small picture, guys. So one by one, so we'll see. It is not small picture, it is big picture only. First of all, I will create a network, just for a general idea purpose only. Okay, this is the device I connecting like this. Okay, do not think guys wired or wireless kind of stuff. Okay, okay, so this is one network and this is a another network. I can put a three networks, four networks, I can do it, but space, time and space important, right? For example, I put a A1. Just for our understanding, I put this. Okay, so this is one network. This is another network. Think like this is the network one. I put a network one. Okay, just for our understanding, guys. So I didn't told you, but just I'm telling here. Hub or a switch, which generally, so in a wide type of LAN communications, use hub or a switch. Okay. Same goes for this one also. Whether we use hub or a connected devices through hub or a switch, not this concept, but not for a definition. Just I'm trying to say. So like one LAN communication. This is another LAN. This is another network. Two networks. Of course, you can. Some people asked me, sir, can we connect directly like this switch to switch? Think like there are in a not there in the same location. Okay, think like there are separate subnetwork, different locations. So what to do? Okay, so this is one network, that is another network. Guys, understanding?
Yes,
Yeah,
sir.
yeah, very good.
Yes, sir.
So there are two different networks, maybe apart separately. Okay. Now I want to make communication between these networks. Think like this: you are sitting in one place, I'm in sitting in different place. We are able to communicate, right? Both are in different networks, both logically and physically. Right. Okay. Yeah. Don't worry about that. What is this thunder kind of stuff that represent WAN connectivity? Okay. Okay. Perfect. What is this device? I told about a device here. So what is this device? It is nothing but a router. It's not about size. This is length. This is good now. Okay, so think is this is a one network. Drawing in this one will take lot of time. Okay, so it is. This is a network. This is a network. This is internetwork totally. Okay, internetworking device. So what I am trying to say, guys, here I use a router. What is this router? Only I am telling. What is this router? Internetworking device. Internetworking device. Okay. Router is a internetworking device. So guys, again, network, networking, internetworking. Network means connection of interconnection of two or more devices. Networking means communication between interconnected devices. What is internetwork? Connection of two or more networks. Communication between different networks is called a internetworking. For internetworking, we are using a router. In the network, we use hubs, switches, kind of stuff. Okay. Of course, there is a lot of devices are there. I'm not going with them. Okay. Guys, for a network, we need a physical connectivity. Physical connectivity. Need a physical connectivity. So the how you connect it, way of devices connected physically called a physical topology. For networking means communication. Forget about internetwork and all. Okay, just networking. Of course, for networking, compulsory we need a physical connectivity and logical addressing, logical addressing and protocols. Okay, without physical connectivity, either it is wired or wireless, guys. Lot of people think so. Physical connectivity means I'm using Wi-Fi. No, 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 no. Physical connectivity does not mean wired or wireless. The way of you are connectivity. That's it. Okay. Of course, you need a connectivity. Without connectivity, you can't communicate. Okay. Okay. Without connectivity, you can't communicate. Without logical addressing, you don't know how to communicate. To whom to communicate. Without protocol, what you communicate, we don't know. Okay. So this is the call. But first of all, I'm trying to tell about a physical topologies. Just I'm trying to tell physical topologies. What are the physical topologies? sorry, bus topology, ring topology, mesh topology, star topology, hybrid topology, okay, hybrid topology, and point-to-point topology, point to multi-point topology, tree topology. Recently, tree topology is also came. Okay, so this is the point. Okay, logical addressing means IP addresses. Protocols are protocols only. Okay, guys, again I'm telling, you want to create a network means it is a physical connectivity. You want to create a network means it is a physical connectivity. The way of devices connected physically called physical topologies. Way of devices connected physically called physical topology. Okay, networking. Network means communication. Communication between devices. Of course, you need a communication. Of course, we have to need a physical connectivity, means you have to connect the devices, and we have to give an IP address, and then protocols. Okay, protocols. We need to communicate. I am adding one more thing, that is NIC here. I will tell these things also. First one I want to tell about a physical connectivity means physical topologies. That way of device connectivity. Okay, these are the physical topologies. Yeah, someone is trying to ask question. Tell me guys, anybody added? Avanish Tirupati came. Okay, Avanish Tirupati. Okay, so this is one by one. I will try it. Guys, up to here, understand? Up to here.
Yes, sir.
Yes, sir.
So I can explain this one. If you okay, then okay, I will proceed. Once I completed this one, I will give you a break. So drawing in a paintbrush is much better, but I will try here. I already tried, but it is little slower and not colorful. Guys, what is a bus topology? I have a devices. I have a devices. Okay, I connected these devices like this. No, I will remove this one side. I have a devices like this. Yeah. Okay. So I have a devices. I have a devices. For example, this is ABC, BPC, C, D. Okay. Now I am trying to connect these devices to a backbone cable. Just I will tell. I don't write about this one. In the PPT, there is a explanation about it. You can try. Okay. Just I will tell, draw, and tell in orally. Okay. So devices are connecting to the backbone wire. So all are communicating through this backbone wire only. So you want to send a message to C, it has to go to the backbone wire only. Okay. This is a bus topology. Devices are connected to a backbone wire. It is very simple to configure, but there is a difficulty to troubleshoot. What is the problem? If backbone wire is somewhere cut, for example, this cutting is happen, some disturbance or some cut happen. Wire is, it usually cuts. When it is cut, further communication will stop, and you should know where it is disconnected. You have to search entire cable where it is connect. Disconnection is happen. Okay, and if more devices increases, lot of traffic on a single backbone. It is a 4 device. I have 100 devices. All 100 devices data travel through one single backbone cable. So you need a lot of bandwidth cable it is required. Okay. So this is bus topology. Guys, understand what is bus topology? Hmm?
Yes, sir.
Very good. So here it is. I have a devices. I have a devices. These devices are connecting like this. One device is connected to another device. One device is connected to other device, and this device is connected to another. Like A is connected to B is connected to C is connected to D is connected to E is connected to A. Means the last device is connected to first device. Like that, a ring will be formed. Like that, a ring will be formed. A ring will be formed. And how it will be communicate? A want to send a message to D, A to D, A to B, B to C, C to D. D want to send a message to A, D to E, E to A. It means it communicate in one direction. It communicate in a one direction. A to B like that, or E to A. It's like a clockwise or anti-clockwise direction. It is, of course, works based on an algorithm, difficult to scaling. Scaling means ability to improve your size, infrastructure size. Correct? Scalability means ability to increase scalability. Scaling means increasing. Okay. So I added one more device. For example, this is the F I added. Okay. Again, I have to connect like this. Again, I have to connect like this, and then like this. I have to remove this wire. Again, entirely how to go, how to communicate. Go to each and every PC and tell how it should be communicate. Okay. So this is we call it as a ring topology. Okay. So this is a ring topology. Yes, understand ring topology. Each device, one device is connected to other device is connected to other device is connected to another one. Finally, last device is connected to first one. And they will communicate either clockwise direction or anti-clockwise direction. What is the problem? Difficulty to scalability. If one device is down, for example, the C device is down, communication stops. A cannot communicate it to E. E to A communication is there, A to E communication is won't be there. Okay. For example, this wire is down. Okay. C, D, E, A, B communicate. A, B communicate. But B to C communication is there, not there. A, C communication is there, not there. A to E won't communicate. E to A communicate because of only this single wire. Okay. This is the ring topology. The next one is, guys understand bus topology, ring topology?
Yes, sir.
Very good.
Yes, sir.
I have a devices A, B, C, E, E. So A think like this. This is the problem with this Google. Yeah, can anybody guess what topology it is?
Star.
Star topology.
Very good. Okay, so when we see a star, automatically we think it is a star topology, but it is not a star topology. It is mesh topology. Istan sir, just took 5 minutes further. Istan.
Sir, can you please repeat?
It is a mesh topology because first of all I draw a
Next,
star now. Yeah, mesh topology.
every device is connected to each device. Sir.
Yes, very good. So to make it more easy connection for a drawing purpose, people put a star, but it is not star
Okay,
top.
sir.
When you see the star symbol, immediately we think it is a star topology. It is not a star topology. It is a mesh topology. Yes, very good.
Okay,
Every
sir. Thank you.
device is connected to all other devices. Every device is connected to all other devices.
Mesh
Mesh top.
topology.
Every device is connected to all other devices. What is it? Highly redundant. Think like this. If this cable is down, if this cable is down, what is this? Okay. Okay. If this cable is down, no problem. Only B to C direct communication is stopped. B to C communication stops, but remaining communication is available. Okay. For example, this device is down. Remaining devices will communicate. Only C is not available. Okay. This is the mesh topology. Every device is connected to all other devices. It is a redundant, means if one way is not working, other way it will work. Okay. And it is a very complex and lot of wiring is required, and it is complex, difficult to troubleshoot, difficult to scale, difficult to scale. Think like this. I added a one more device. Okay, for example, like this. What I have to do? I have to draw all connections from here. Okay, I have to go to each and every device. I have to connect like this, like this, like this. Means every time you have to connect. Difficult to scalable. Okay, you don't use daily basis, but Okay, we don't use in a regular data communication. Of course, we don't use ring and bus topology also, but mesh topology we are using in like a SAN type of communications. SAN, SAN boxes, SAN storage devices are there. SAN type of storage devices, servers, where more redundancy is required in that server rooms, core routing places like ISP service provider
Maybe cyber
having top
cafes.
level routers. You tell me.
Maybe cyber cafes use mesh topology.
Cyber cave don't use. They're also star topology. I'm telling internet service provider. You are getting internet, right? Internet service
Yes,
provider,
sir.
and they are also having lot of routers. Okay, main core routers are there, top level routers, high end level routers are there. If one router is down, total network will be down. So instead of that one, they put a 4 or 5 routers and configure in a mesh topology. Okay, it is small in size, but mainly if one device is failure, no problem, we will get from a other device. So in that cases, we configure a mesh topology, not in a regular network. These all topologies we don't use in regular networking part. I will tell two more topologies. Okay. So next one is star topology because space is not there. So then I will go to the next page. So yes, the original star topology is like this. We have a devices like a starting a written about a network, right? So it is look like that one only. So we use a centralized device in the star topology, like a hub. Okay, so the devices are connecting directly to this hub bar switch. So this is a star topology. Okay, this is a star topology. You have a devices, for example, like this. Devices will communicate it through this switch only. It is very easy to configure. First of all, it is very easy to configure and easy to troubleshoot. And we are all using a star topologies only. We are all using star topologies in our regular communication. Okay, and regular LAN communication, we are using a star topology. It is easy to configure and easy to troubleshoot. But we should use a centralized device. We depends upon the centralized device. For example, one wire is down. This wire is down. No problem. Remaining devices will communicate. If one device is down, no problem. Remaining communication will be go on. But centralized device is down. Think like this, communication will stop. But hubbar switches having a LED status, that's we can understand where is the issue is occur, a total issue is occur. We can easily understand, we can easily troubleshoot. That is a star topology. Next one is other challenges of um, other challenges of a remaining topologies are scalability. Scalability. What is scalability? Ability to increase your infrastructure, or ability to increase your infrastructure size. Means I have a more number of devices are there. So how to connect? 100 devices are there in the same LAN. How to connect? The switch port is very limited. Hub or switch, the port numbers are limited, but still we can do by connecting like that. Okay, by connecting the devices. Okay, like this. So by connecting this switch to switch, so they will easily communicate each other. So I'm putting this another one like a, it is not different network guys, just for our understanding I'm putting these numbers. Initially both are different network, now it is both are same network only. Initially both are different network, but now this is a same network only. Okay, so this is called a extended star, this part. Okay, this part, this is star topology. Now we are connecting two star topologies together, that is called extended star. It's a extended. Okay, extended star means this is, we are extend the our star topology. Guys understand star topology? It is very easy to configure. It is easy to configure. Okay, easy to troubleshoot and easy to scalable. Easy to scalable. Okay, only thing is you have to pay additional money for a centralized device. We are using a centralized device called a hub or a switch. Okay, we are using a centralized device called a hub or a switch. So that is a, okay, so that is a part. Okay, but not redundant. It is not like a non-reliable type. Okay, guys, you have a device and there is another device. You are connecting directly like this. You have a, this device is there. You are connecting directly. Okay, you are connecting this type of connection. We call it as a point to point connect. Point to point. Okay, this topology we call it as a point to point. Point to point topology. Okay, this is the point to point topology. Well, I will tell point to multi-point, but the space is not there. Okay, you don't get more space. This is better. Okay, point to multi-point. For example, this is A. This is R1. This is R2. Okay, a direct connection of a two devices is called a point to point. Okay, that is the first thing. Next one is point to multi-point. If you see this switch topology, this is star topology is also a point to multi-point topology. Means one device is connecting to multiple devices. One device is connecting to multiple devices. Okay, for example, it is connected to this. Think like this. This is connected to this. This is the point to multi-point topology. Okay. Okay. So point to multi-point topology, and hybrid topology means combination of two or three topologies together, called a hybrid topology. Taking more space. Okay. And the last one is, guys, tree topology. That is, I will take from here only. This is a tree topology. People are nowadays putting this in a picture. That's why I'm putting. Okay. So tree topology. Okay. See, this is the backbone wire. This is the backbone wire. This is some different topologies or nodes are connecting to finally in a backbone cable. Okay. There are different networks are connected to this backbone cable by for a communicating. So this is what we call it as a tree topologies. Guys, this is a your physical topologies. Okay, after break we are going to discuss about a LAN man communications, NICs, few things are there. That's it for now. Take a break. So it is come back in 12:05.
Thank you,
Okay.
sir.